Since the dawn of civilization, we have gazed at the stars and wondered, are we truly alone? Billions of suns blaze across our galaxy, each offering the possibility of alien worlds teeming with life. Yet, when we look up at the night sky for signals, we are met with silence. This begs the question, is life extremely rare or just hard to detect?
I'm always interested in questions where there's a collision of ideas that appear irreconcilable, right? They don't fit with each other. And I think that that collision of ideas in cosmology is very vivid when you bring it together with biology, which is that we are physically insignificant, but it is possible to argue that we are remarkably valuable, notwithstanding our physical insignificance, because it's possible to at least argue that the number of civilizations in a galaxy like the Milky Way might be, on average, 1 or less.
Our galaxy, the Milky Way, is estimated to contain between 100 and 400 billion stars, and at least as many planets. A new study suggests there could be 60 billion planets in our galaxy's habitable zones, regions capable of supporting life. For a planet to support life as we know it, it must have liquid water, energy, and nutrients. These basic ingredients appear to be common throughout the universe, but we have yet to find evidence of other civilizations. So, where is everybody?
Well, it's the Fermi paradox. So the Fermi paradox, going back to the great physicist Enrico Fermi, is essentially the question, where are they? You base that on the observation that, let's say there are somewhere between 200 and 400 billion suns in the Milky Way, something like that. We think a lot of them have planets. Many of them have potentially Earth-like planets. So you have 13 billion years of time. You have hundreds of billions of suns, probably trillions of planets. And so it is a reasonable question to ask, why not? Why has a civilization not arisen ahead of us? So let's say 1 billion years before us. Why has no civilization escaped its home world, apparently, and essentially written its existence across the sky? Why is that? Why don't we see anybody? One of the arguments is often framed in terms of self-replicating machines, so-called von Neumann machines, after the great mathematician John von Neumann. And so essentially the idea is that what are we? What's a human being? It's a replicator, right? So it's a physical object. It operates according to laws of physics. That's what we do, and we replicate. And so it seems that there's no reason why we couldn't build replicators that are essentially, AIs, basically, right? It's almost like an AI-controlled 3D printer with some mining stuff attached to it, and you send it off to the asteroids or to Mars or to Alpha Centauri, to the system there and all the raw materials will be there to allow this thing to replicate. And then you can build a kind of a model of that, how those replicators might spread throughout a galaxy. And people have done this, of course. There's a great book, as an aside, I would recommend, by John Barrow and Frank Tipler, which is a huge influence on me, called The Anthropic Cosmological Principle. And it's a very famous book. There's a great series of calculations in there just showing you how you might estimate, if you could build one of these self-replicating machines, how long would it take, given some reasonable technology, to move between star systems? How long might it take to replicate itself? And you end up with calculations that say that if someone had done that, even a few 100 million years ago, those machines would be everywhere. It's like a virus, right? In a sense, it just propagates. It's an exponential growth of these things. And so you would cover the galaxy in them. And it is true that we haven't observed any. So you might say that that's evidence that nobody ever did it. Or, in the spirit of being scientific about it, you could think, well, yeah, maybe these replicators are the size of a phone. Maybe they're tiny. Maybe they're so advanced that they're in the solar system and we don't recognize them. So you can argue about the Fermi paradox, But broadly speaking, it's the observation that we've looked a bit, and all our observations in the history of astronomy, of all the observations we've made, we have never seen evidence of anyone else. And so that's and it is a paradox, because there's been so much time and so many planets, and it would seem as if somebody should have done something that we could see, and they haven't, as far as we can tell.
Research in the Fermi paradox often considers that advanced civilizations might not last long enough to be easily detectable. They may be transient on a cosmic scale, meaning they arise and then disappear, due to factors like self-destruction or natural catastrophes. Researchers argue that if technological civilizations routinely self-destroy or otherwise burn out, then the chances of overlapping with our own window of detectability become very small. This short lifetime would explain why we don't see evidence of them today.
Carl Sagan famously said it's possible that civilizations don't get beyond this stage that we're at. So when you industrialize as a civilization, so the pre-spaceflight era or pre-interstellar flight era, you will hit problems which are probably common to all civilizations because they're just part of the laws of physics. So one of them is the challenge you pose to the climate of your planet. As you industrialize and build a bigger civilization, you'll use resources, you will affect the atmosphere of the planet and so on. So there's a challenge, and you have to manage that. There's the development of nuclear weapons, for example. So at some point, you will develop nuclear physics if you're going to be a spacefaring civilization. So you will develop the ability to destroy yourself, which is kind of, it's not long, but you go back 100 years and we didn't have the capability to destroy ourselves. Now we could choose to destroy our civilization. So it may be that those challenges are very difficult to navigate. It may be just kind of one of those, not quite a law of nature, but a law of societies, that they're just not able to navigate the challenges that industrialization and the development of nuclear science and so on raise. We haven't passed that test yet. So, there's a name for it. It's called the Great Filter. So one of the arguments, so what we're asking here is there a filter that, let's say the filter's in our past. So let's say that it's just the difficult thing is for life to go from single cell life to multicellular life. And that does look difficult, by the way, as far as we can tell on Earth. So maybe that's a filter, maybe it just doesn't happen very much. So there are microbes everywhere and nothing very complex. Then we'd be happy, right? Because we've gone through the filter. But it could be the filter is in our future. It could be that it's now that you get this capability to affect your planet or destroy yourselves through war or whatever it is. That's a filter, and we're approaching it. And it could be we don't pass through it. And that would also be a solution to the Fermi paradox.
Many people in the general public feel the Fermi paradox needs no solution because they believe aliens have already visited us. However, in science, extraordinary claims demand extraordinary evidence. One related idea is the zoo hypothesis, which suggests that advanced extraterrestrial civilizations do exist, but intentionally choose not to interact with us, much like zookeepers who keep animals in a zoo.
Yeah, I suppose you have to accept it's possible, except that the zookeepers don't hide themselves from the animals. So you could say they're pretty good at it. We're getting better at observing the universe and looking for signals in the universe and so on. So they're doing a really good job if they're sort of tracking our detection capability and continually avoiding, so I don't know, it's possible.
Recent estimates using the Drake equation suggest that the Milky Way may host very few detectable civilizations, potentially only one: the human race. While earlier estimates were much more optimistic, this updated perspective takes into account the possibility that civilizations may not last long enough to become a spacefaring civilization.
But we don't know how many civilizations might there be in a galaxy like the Milky Way, for example. We don't know the answer. How many worlds support life in the Milky Way galaxy? We don't know the answer. We only know of one at the moment. Although I think most people would guess that surely there must be other places, even perhaps within our solar system, where life exists. But we don't know that at the moment. And so what ultimately we can say, I believe, is that we should behave as if we're the only civilization currently present in the Milky Way. That should be our approach to the way that we manage our civilization and our planet and the way that we plan our future, even though it might not be right, because we have no data, essentially.
Ultimately, the Great Filter hypothesis should serve as a wake-up call. It reminds us that if detectable civilizations are indeed rare, perhaps because many self-destruct before reaching advanced spacefaring stages, then we must be vigilant in safeguarding our own survival. In essence, if we are alone in the Milky Way, our failure to overcome our own challenges could extinguish the candle of consciousness in our galaxy forever.
I think it was Carl Sagan again who argued, if a civilization like ours becomes a spacefaring civilization, so multiplanetary and then interstellar, then you have to have solved these problems that cause us to be violent, predatory. And so he suggested that as you make progress and become more powerful and navigate these problems, as we said, these filters that may lie in the future, so you have to, for example, learn to get on as a planet, as a civilization, as one civilization on one planet, in order to flourish and to go out to the stars. So he would argue that, I think he did argue that maybe these other civilizations would have solved this problem. And so they would not expect a violent sort of interstellar, a violent civilization to come in, as you see in science fiction films, and try to take over everything, because violent civilizations like that don't really solve the problems that are necessary to build interstellar spacecraft. That's what. Now, whether he's right, it's coming. Maybe he's being optimistic. The power of the Fermi paradox, ultimately, it's not dogmatic. It's the opposite of being dogmatic. It's saying, given that we have not yet observed anyone, what might the reasons be? And that's an interesting exercise. But it's not to say there isn't anybody out there. It's to say there's an observation here that we don't see anyone at the moment. So why might that be? So you're right, it might be everyone hides, or it might be that given what we know about the history of life on Earth, it's just very rare that complex living things emerge. Professor Brian Cox, Horizons, a 21st century space odyssey, live on stage.